there. Today, we will be learning about forces. At the end of the lesson, you should be able to explain the meaning of force, identify contact and non-contact force, differentiate between magnetic and gravitational force, measure and calculate gravitational force, GF, when mass and height is provided. In school and at home, we see many things moving. We move about on our legs, vehicles move on roads, train on wheels, aeroplanes fly in the sky, and ships sail on the seas. Movement occurs when a force is applied on a thing or object. That is, force causes things to move and can also prevent things from moving. A force is a push or pull of an object. Push and pull comes from the objects interacting with one another. There are two types of force. They are contact force and non-contact force. Contact forces are forces that act on a body either directly or indirectly through a medium. Examples include push, pull, tension, friction, and upthrusts. Non-contact forces are forces that act through spaces without making direct contact with the body. Examples are gravitational force, electric force, and magnetic force. Let's now look at magnetic and gravitational force. Magnetic force is defined as an attractive force between magnetic and non-magnetic objects. For example, a magnet can attract iron filings before the magnet comes in contact with the iron filings. This phenomenon shows that magnetic force acts over an area around the magnet. Thus, a magnetic force is called a field force. Gravitational force is a force that attracts any two objects with mass. It is called an attractive force because it always tries to pull masses together. It never pushes them apart. This is the reason why objects above the Earth falls down to the Earth. The SI unit of force is the Newton, and its symbol is N. The force acting on an accelerating body of mass m is given by F equals ma. Let us now look at the calculation of gravitational forces. The value of the universal acceleration on the Earth's surface due to gravity g is 9.2 meters squared or 10 meters squared. To calculate gravitational force GF, GF is equal to mg, where m is mass and g is gravity. Therefore, F is equal to mg, where F is force and mg is mass times gravity. This is used for calculation of gravitational force. Let us now look at some examples. Example 1. Calculate the gravitational force needed to pull down an object of 5 kilograms. To find the solution, given F is equal to mg, where m is 5 kilograms, g is equal to 10 meters squared, and F is unknown. F is equal to 5 kilograms times 10 meters squared. This is equal to 50 Newton. Therefore, the force needed to pull down the object is 50 Newton. Example 2. Suppose you lift an object of mass 2 kg from the ground to a height of 11 meters. Find the work done in lifting the object. In this contest, if the object is lifted, work is done against the force of gravity. When work is done, energy is transferred to the object and it gains gravitational potential energy. Work done against gravity can be found using the equation work equals force times height. Since force is equal to mass times gravity, we can use the equation W equals mgh, where m is equal to mass, g is equal to gravity, and h is equal to height. Work done is measured in joules. To find the solution, m is equal to 2 kg, g is equal to 10 meters squared, h is equal to 11 meters, and w is unknown. W is equal to 2 kg times 10 meters squared times 11 meters, equal to 220 joules. Therefore, the work done in lifting the object is 220 joules. We have now come to the end of today's lesson. We learned about the meaning of force, identified contact and non-contact forces, explained magnetic and gravitational force. Finally, we looked at a few examples on how to calculate gravitational force. See you in the next lesson.